let's talk about how particles in a gas behave. They're spread out, they move freely, they move randomly, they move at a range of different speeds, but quite quickly on average. They move in straight lines until they bump into something, whether it's the wall of the container or another gas particle. Every time a particle hits something, it exerts a tiny little force on it, a little push. Now on its own, that force is absolutely tiny, it's negligible, it's almost nothing. But when you have lots and lots and lots of them happening every second, they all add up. Now in just 1 meter cubed of air, which is, basically the box that you're looking at me in, there are 10 septillion air particles. That is 1 with 25 zeros after it. That is a lot of gas particles, so you can imagine there's a lot of collisions happening every moment. So all of these forces do add up into something called the pressure. This is gas pressure. It's literally just a combination of all of these particles bumping into each other, bumping into everything around it, exerting tiny little forces, all combining. Now, increasing the temperature of a gas increases the speed at which the particles are moving. Now that means that each little collision will have a bit more force behind it. It also means that collisions are going to happen more often because the particles are moving faster. So that means increasing the temperature of a gas increases the pressure in the gas as well, as long as we keep it at a constant volume. In fact, volume, temperature and pressure are all related. If you keep one of those 3 things the same and then change one of them, then the third one will change as well. So if we have a constant volume and we increase the temperature, we also increase the pressure. If I keep the temperature constant, then the pressure and volume are inversely proportional. Increasing one will decrease the other and vice versa. If I keep the pressure constant, then temperature and volume are directly proportional. Increasing or decreasing one will make the other one change in the same way. Now, finally, let's talk about something called Brownian motion. We said that these gas particles move in a straight line until they bump into something. Now, in this example over here, I've coloured in one of the gas particles. I've done that to make it a little bit easier to follow with your eyes. Look at what it's doing. Follow the pathway that it's tracing out. It looks very, very random. Now, we know that it's not random. It's just going in a straight line until it bumps into something. But if you took that particle on its own, it would look like it's making this really crazy random pathway. And that's called Brownian motion. It's the apparent random pathway that gas particles make. Interestingly enough, work on Brownian motion is what won Einstein a Nobel Prize. So congratulations, you are now basically as smart as Albert Einstein.